So you made it. You made it to soil fertility here at Arkansas State University. I hope you are ready for a semester of hard work, but a semester where you will learn some things that you will use in your career. The students that take this class during the semester, they make comments of, "This is a really hard class. We have to use math and chemistry in this class." Or, "Dr. Green, are you and Dr. Greenwald working together trying to make your courses difficult?" The answer is no, we're not trying to make it difficult, but this material is extremely important for your success in your career. The fertility of the soil and applying the correct amount of fertilizers in the right conditions is absolutely essential. This first week, we are going to basically be reviewing material that we discussed and learned back in introductory soil science. So I'm going to go over a few things, but I want to put this course, soil fertility, into context. We are here studying soil fertility because of our need for global food security. Global food security, national food security, regional food security, personal food security. It's because we need to be able to provide food for a growing population. So I want you to, before we meet again, I want you to think about these things. I want you to think about what the population of our country and the population of the world has, what I want you to think about that in terms of this past century. How has the population changed in the past century? How has our food production changed in the past century? I want you also to think about the number of farms in the United States and the number of acres of farmland in the United States in the past century. You can think about it from 1900 to 2000, go from 1920 to 2020, but think about it in the context of 100 years. How has the number of farms and the amount of farmland changed in the United States? I want you to think about yields. How have our yields of various crops changed over the last 100 years, or really more importantly, over the last 50 to 75 years? Because that's where things really started happening. And then I want you to look at fertilizer use. How has our fertilizer use changed over the past century? Not just in amounts, but in the kinds of fertilizer that we are using, the kinds of nutrients we are using to grow our food. And be ready to discuss this the next time we meet. Back in introductory soil science, we learned about the 17 plant essential elements, and we spent roughly a week talking about all of the nutrients. We're going to spend the whole semester talking about the plant essential elements, as well as some of the soil properties and soil chemical interactions that affect these plant essential elements and the ability of plants to take these elements up and utilize them. So if you remember, we have some major macro elements. Carbon, hydrogen, and oxygen are the macro elements. We've got macronutrients: nitrogen, phosphorus, potassium, sulfur, calcium, and magnesium. These are nutrients that are taken up in large quantities. Then we've got the micronutrients: chloride, iron, boron, manganese, zinc, copper, molybdenum, and nickel. Now pay close attention. I used the term chloride, not chlorine. Chlorine is a gas with the designation of Cl2. Cl2 is a gas, and it's chlorine. Chloride is what we're going to be referring to. And so anytime we are listing or talking about the micronutrients, we're going to use the term chloride because that is the term that is understood in soil fertility. We're not going to use the term chlorine. If you put chlorine down on a quiz or an exam, I will mark it wrong. The term is chloride. There are lots of different factors that affect crop growth. Climate factors, soil factors, and crop factors. Of course, we're going to focus on the soil factors. This is soil fertility, but we cannot ignore climate factors and crop factors. So let's just talk about those very briefly. Climate factors, we're talking about precipitation. If you think about climate, the first thing you're going to think about is rainfall or lack of rainfall, depending on where you are and what time of year it is and which year it is. Sometimes we have too much. Too much precipitation causes problems. Sometimes we have too little rainfall. Likewise, that causes problems. So we get into the twos, too little, too much, but precipitation is the main climatic factor that most of us worry about. Air temperature is also important. Humidity, light, the altitude or latitude. You know, you're sitting here in the Delta region in Arkansas, and it's flat, and we've got really good growing conditions. But you think about other altitudes, other latitudes, things are different at those altitudes and latitudes. Wind can be a problem, or wind can be a good thing. We generate electricity with wind turbines. However, sometimes we get into problems from wind damage. Have you ever been in a situation where everything looked good and then a wind storm came through and you lost a crop? In 2020, there was a storm system called the derecho that came through the Midwest and destroyed a lot of acres of corn. A windstorm that destroyed acres and acres of corn. So wind can be a problem. Let's look at the soil factors. One of my favorite soil factors, of course, is organic matter. Organic matter runs the system of the soil. And we'll talk more about organic matter as we talk about these various nutrients and different aspects of the soil this semester. The texture of the soil has a huge impact on soil fertility. The texture, of course, has an influence that you already know from introductory soils, that clays have a higher CEC. And a higher CEC means that that soil will be able to hold on to more nutrients. So texture plays a huge role in soil fertility. The structure of the soil has an impact, especially on drainage and infiltration, but also affects the fertility of the soil, because anything that affects drainage and soil saturation is going to affect the fertility of the soil. Cation exchange capacity, I mentioned that, along with texture. The base saturation of that cation exchange capacity, how much of that are basic cations versus acidic cations. We'll talk more about that. The topography. Remember the 5 factors of soil formation that Dukachev and Hans Jenny developed? Topography is one of those. It affects the soil fertility and the ability of plants to grow. Soil temperature has an impact. Soil management, what you do on your land, has an impact on the fertility of the soil. Soil depth, How much of that soil are those roots able to explore? So you may be sitting in a part of the country or a part of the world that you think is normal for agriculture, but do you ever think about what other parts of the world, this is in the tropics, growing growing crops on hillsides? This is the part of the United States, in a mountain valley. You've got the mountains in the background, but crops are grown in the valleys. So just because you think you know agriculture from where you're sitting, we need to think about um, agriculture in a larger perspective, because you don't know where you're going to be sitting 2 years down the road, 5, 10, 20 years down the road. For me personally, I grew up in California. I've lived in Utah and Indiana, Maryland, now here in Arkansas. I lived in South America for a couple of years in the country Chile. By the way, Chile is known for its grapes, its peaches and nectarines, avocados. That is a highly productive country in terms of agriculture. So just because you are where you are now, you need to be thinking about the larger agricultural landscape, because you don't know where you're going to be later on. So as we discuss these things related to soil fertility, and I bring in examples from other regions, you need to pay attention to those as well, because these are principles that we are learning, but how we apply those principles may be different in different contexts. From the crop factors, the crop variety is important. The planting date, the row spacing, the seed quality, evapotranspiration, water availability, nutrient uptake, pests, harvest efficiency. These are all crop factors, but they intertwine with soil fertility because they affect a potential crop yield. And the potential crop yield is one of the things that we have to take into account when we are determining how much of a nutrient is going to be needed by that crop, and then how much of a nutrient we need to supplement. You remember Mr. Liebig? Justus von Liebig, the law of the minimum. One of my favorite scientists, Liebig. Liebig is basically going to impact this course immensely. Remember, he said the most limiting factor determines yield potential. With that, if you do not remove the most limiting factor, your yields cannot improve regardless of what else you do. We need to take this into the context of food security. We need to think about this in the context of sustainability and environmental impact. We need to take this in the context of profitability. You need to be profitable. If you're farming, you need to be profitable. If you are consulting, you need to make sure that your producers are profitable. And profitability and environmental sustainability can easily go hand in hand. Environmental sustainability, profitability, food security, they can all go hand in hand. And we're going to be discussing how that can happen this semester. So stay with me. It's going to be a ride. I want to discuss with you a little bit about what we're going to be doing this semester in terms of actual assignments. The syllabus is available to you. You can look at it, you read it, you know how to read, but I want to emphasize a few things. We've got 2 exams and a final exam. We will also have weekly problem sets. These are assignments that you need to do every week. There will be 12 of them, and you will be able to drop your 2 lowest scores of those problem sets for whatever reason. We will have weekly quizzes on the chapters that we're studying. There will be 12 of them. Once again, I will drop your 2 lowest quiz scores. For whatever reason, your 2 lowest will be dropped. There will also be a soil nutrient portfolio that you will put together. There's a whole section available to you that goes through what is required in those soil fertility portfolio or soil nutrient portfolio. But let me explain why we're doing this. Semester after semester, I have students that come back after they've been gone for a year or two after they've graduated and say, Dr. Green, can I get your soil fertility notes, your materials? The answer is no. But what I'm doing now for you, for your benefit, is to help you organize your material during the semester so that you have that material to utilize. Now, why would somebody want their soil fertility material? If you're a crop consultant, you may want to refer back to some of the things that we've discussed. If you are studying for the CCA exam, the CCA exam, there's a large portion of the CCA exam that is directly from soil fertility. So if you're trying to pass the CCA exam, this course is absolutely critical for you to be able to pass that exam. So the soil nutrient portfolio is what I have put in place to help you organize your notes, organize your semester, and you can refer to that document later on. To prepare that portfolio, look at the assignment guidelines. We will try to have a few field trips this semester. We'll also have a math and chemistry review that is due at the end of the semester. I'm going to give you here at the beginning of the semester basically some examples of things you should be able to do, chemistry and mathematics. We're going to be using chemistry. We're going to be using math all throughout the semester. You need to know how to do these things. They're not hard. You should already know them, but I want to make sure that you know what they are. And then towards the end of the semester, we will have a math and chemistry review quiz to make sure that you understand how to do these things. That's going to be worth 50 points. Now, here's the last thing I want to really emphasize. In this course, we'll be taking 5 competency quizzes or competency assessments. These competency assessments are things that I think are so important that you need to have these things totally memorized, understood. You need to know these things, not just have known them. You need to know them. And you need to pass these 5 competency assessments at a 100% level. And I'm on in the syllabus, I have identified what those things are that you need to know. I will reiterate those as the semester goes along. The first one is to list all the plant essential elements in their correct categories with their name and their chemical symbol and spelled correctly. That's competency assessment number 1. And you have to pass at a 100% level. If you do not pass all 5 competency assessments, regardless of how well you do in the rest of the class, you will fail this course. Now, here's the thing. You may not pass it the first time. I understand. And so I will give you opportunities to retake the competency assessments. So let's say you pass the first competency assessment the first time around. That's worth 20 points. The next week, I will offer that competency assessment again for retake. And then it will be worth, the maximum you'll be able to score is 18 out of 20. You're basically going to be reduced 10% each time you have to retake it. Now, don't be fooled in thinking you can just not show up and not take it that second time. Each time the retakes are offered, that will reduce your potential score. Whether you take it or don't take it that time, your score will be reduced. So list all 17 plant essential elements and then label the nitrogen cycle. A third competency assessment, listing the chemical forms of each of the 14 nutrients that are taken up by plants. And then calculating fertilizer application rates based on nutrient recommendations. And then assessment number 5 is to calculate a bulk blend fertilizer based on nutrient recommendations and then calculate the cost of that bulk blend. So these are competency assessments that we will do throughout the semester. The first one will be in 2 weeks. The last one is towards the end of the semester, and we'll just be taking these incrementally throughout the semester as we discuss that material and I prepared you for that assessment, then we'll take the assessment. That's in addition to the weekly quizzes. That is in addition to the exams, in addition to the weekly assignments. So is there a lot going on in soil fertility? Yes, there's a lot going on. You need to dedicate some time to the study of soil fertility. But working through this together, we are going to learn some things that you will use during your career, like on the first day on your job. This is so important. I'm sure all your professors tell you their material is so important, but in this class, soil fertility and fertilizers, I hear students again and again and again come back after they've been out in the workforce for a year or two saying, this course is what helped me in my career. This course is what helped me pass the CCA exam. We're going to do this. This is going to be a fun time, but this is going to be some work. So get prepared to work, and I'll be here with you the whole time. Let's rock on.